Hey folks, wanted to take a moment here to talk about custom systems. We're just about to ship this system to a client, just in the final stage of preparing it here, and it turned out pretty good, and I figured I'd just take this opportunity to make a video about one of the things that the various things that we can customize. Like for example, here's our standard offering. We have this kind of connector on the back here, but one of the things that we can do is, in terms of customization, make it so that it has what we call a flying lead on it. That is a bunch of wires, not just a connector. Another way in which we can customize a scanner is by putting a different connector on it. So for example, this is one that we just prepared very recently for a client. It has a different connector. You see, this is our standard connector. This is a little bit smaller. And in fact, this is on the back side of the board, so it makes it so that the plug comes in from this end. It's a smaller thing that has smaller wires. It's just going to be a lot smaller of a package for the client. And in fact, what you'll notice is this is rotated. Our customer needed the mirror orientated in a different way compared to our typical orientation. So this way we rotated the whole circuit board pattern, and then we put this special connector. So this is just some of the customizations we could do. This is kind of the stuff that makes sense, the easy things. But then this system here is completely custom, and this is what I'm going to be talking about today. So this is our brand new Saturn 15 scanners that we've been shipping for a few months now. It's originally intended for laser marking and cutting, material processing. This customer came to us with a projection application. They needed a special projection angle. So this customer needed to project 50 degrees wide by 30 degrees high, and with a rectangular beam with special dimensions. So we had to come up with a special mirror set for that we designed, and that's this mirror set here. You take a look at how long this Y mirror is and the shape of this X mirror. It's a bit unusual. It's made for a rectangular beam. This is not the XY mount that they'll be using. This is just something we have. We've designed an XY mount for them, and they're having it made. It's more of a what we call the standard orthogonal mount, and this has got the setback. But what's so special about this one is that in order to accomplish their goals, we had to use a special coil configuration and also a special H-bridge driver. So I'll go ahead and show you. This is our standard Mach-DSP. Many of you know this one. It runs at plus or minus 24 volts, and it's really compact. This is 2-axis, the palm of my hand. This is the size of it. So it's a very convenient package. It runs at plus or minus 24 volts. It's capable of putting out into the scanner 10 amps peak and 5 amps RMS. Well, in order to accomplish this customer's goal, they needed more, and I'll have you come around here, Josh, and I'll show you what we've done. Is we have a new, this is a prototype, but it's an H-bridge PWM driver stage here. So what it is this, it's our normal Mach-DSP here. You can see it here. I'm holding it like that. But what we've done is, instead of having the analog power amplifiers on the top like we normally do, we have a H-bridge driver back here. This H-bridge driver is very special for a few reasons. One of them is that it runs at 50 volts. So instead of plus and minus 24 volts, you put 50 volts into it, and the driver here makes a plus and minus supply that it supplies the Mach-DSP for all of the kind of the housekeeping and position sensing and that sort of thing that it normally has to do. But the actual H-bridge runs at 50 volts. And it's, like I say, it's a PWM driver, so it's like a digital driver. It's not an analog, so it runs very cool. Even the job I'm going to show you here, doing it in a second here. But it switches at 600 kilohertz. Which is, as far as I know, the fastest in the industry. And finally, another thing that makes this special is the filtering that we have on the PWM, which I'll talk about why we do this here in a second. But you see the filtering here with the 4 toroidal donuts. Plus there's an additional filtering on the back of the board that you can't really see right here. But what it does is it makes it so that the voltage coming out here that drives the scanner coil really looks like the voltage of an analog driver. It's really clean. Now normally, this is not the first H-bridge PWM driver to appear in the industry. This has been done before, and I'll show you a couple of things that I got on eBay, which is my favorite place to buy scanner stuff. So this is something that we picked up from from eBay. It's a ScanLab. It drives a big Dynaxis L, and they have 2 PWM drivers in here, 2 single-axis drivers. This is a kind of a typical thing for the industry to have single-axis drivers rather than 2-axis drivers. So you can see this is their driver. This one switches at 330 kilohertz, and you drive it with a single 30-volt supply, and it does the rest. It has a little, you see these 2 little donuts here, it has a little bit of filtering, but nevertheless, mostly what it's putting out to the scanner is a square wave. These little donuts here just take the edges off to get rid of some of the EMI, but otherwise, it's really pushing a square wave out to the scanner. So this here is another find I got on eBay. It is a Lightning 2 system from Cambridge. You can see, once again, what we have are 3 single-axis servo drivers with a PWM output stage. And this switches at 100 kilohertz as far as I'm able to tell. I just powered it up. I'm not able to actually put program content through this, but in just applying power and looking at the signal going to the square wave, to the scanner, it is a square wave. And this runs at 48 volts. So ours runs a little bit higher, 50 volts. And like I say, switches at 600 kilohertz. And like I say, the beauty of the filtering that we put on, it means that we have a lot of clients that have scanners here and the servo driver way over there, and they have a long cable, right? We have up to 5-meter cables in stock. We stock everything from really short cables up to 5 meters in stock. And so if our customer wanted to locate this somewhere very distant from the scanner, you could do this with our servo driver because of this filtering that we've got on it. So let me show you the performance that we're getting, which I think is quite good. So this is the standard grid test pattern here. You can see the job it's doing. It is 50 degrees wide by 30 degrees high. And so the performance is quite good. As you can see, it's square everywhere. And what's great about this is if we take a look at the actual current that's being drawn at 50 volts is about 1 amp. So this is the input power, 50 volts at 1 amp going into the Mach-DSP with the servo driver there. This is about as aggressive of a test pattern as this customer will ever do, aggressive as scanning. So that you could expect that they would draw no more than 1 amp at 50 volts for their scanning job. So now I will change to a different test pattern here, which is also recognizable. The ILDA test pattern, and let's see how big we can get that. Get that up somewhere around there. And that is about, let's see, 26 degrees. So this is the ILDA test pattern right now running at 26 degrees, and you can see it's very solid, everything's nice and square, very controlled, and so it looks good. We've got really good performance here that we're delivering to the customer. So now I don't think that anybody else can do this. Let's walk back out here and we'll talk once more about this driver. This has got our Saturn magnetic circuit on it, and so these scanners run cool as a cucumber even when they're doing this job, which involves what we call large signals. This is scanning wide and fast at the same time, and yet these things are running really cool. And with this servo driver, you can see it's just sitting right here. I'm holding it in my hands. It's sitting right here on a wooden desk with no cooling or anything. It runs cool. And this is the power supply over here. It's just a 50-volt power supply. So we're very happy with this, what we've been able to deliver to this client. I'm sure they're going to be very happy with it as well. Like I say, the nature of this video is custom systems. We have, one thing I will say about custom systems is it's going to take a while and it's going to cost money, right? We have systems that you can buy on Edmunds right now. They keep them in stock. Edmunds buys a bunch of stuff from us. They keep them in stock. You can order it today. You can have it delivered tomorrow by FedEx. So the standard stuff that we deliver, you can have deliver very quickly. But for a custom system, it's going to take time because we got to go back and forth. We got to discuss what you want, what you need, how it's going to be, and all these other things. And it's got to be what we call an NRE charge. This is an engineering charge for us to do the work, to make the mirrors and that sort of thing. And then it's going to take time to acquire these custom parts and to put together a system. But we can do it. We can do it, and we will do it. Most other people won't do it. They've got their standard products, and they don't like to do custom systems. It's more of a distraction for them. This is a pleasant distraction for us. We have the people that are kind of crunching through in production. They're making our standard products, and so the engineering team, we got to keep them entertained and alert and you know, challenged. And so this was one of the challenges they've come up with recently and have been able to deliver on that. So like I say, we were very happy with the performance of this, and I wanted to make this video to show our custom capability, custom mirrors, custom coatings on the mirror, custom coil windings in the scanner. Everything we do here is made by hand like a Swiss watch or an Aston Martin. So it's really easy. It's a lot easier for us to do things on a custom basis than it would be for people to kind of crunching these things out in a cookie cutter fashion. So, I hope you like this video, and if you got any questions or comments, put them below. Thanks.